So at the top of the page, literally all it says is if you multiply radical expressions, and it gives you like a textbook definition there, but it says the nth root of A and the nth root of B, as long as they're not imaginary or something like that, as long as they're real numbers. When you multiply them together, all you gotta do, take whatever's under the root and squish it together with some multiplication. That's where you might want a calculator for a couple of these questions today. So, for example, just a little review. Hopefully you've done something like this, at least the square roots in Algebra 1. But if I got radical 5 times radical 10, I'm just going to squish those guys together and rewrite that would be the square root of 50. And then it turns into a problem like what we were doing in our last lesson, where we're just going to break down that radical if we can. Now, if you are in love with the factor tree, please factor tree away, but I would highly recommend try to find the biggest perfect square that'll divide in evenly to whatever number you've got under the square root, and that'll make it a little bit easier to simplify. Anybody know biggest perfect square that would divide into 50? 25. So I would just do this real quick. 25 times 2. And I'm doing that so I can remove any perfect squares. So the 25 is the perfect square. So square root of 25, just remove that. That's going to come out as a 5. And then the 2 is left under the square root. And that's all you got to do. Okay, does anybody remember maybe from Algebra 1? If I have a question like my next problem, I got negative 2 times the square root of 8, and then I want to multiply that by 5 times the square root of 10. What do I do with the numbers outside the radicals? For sure, you just multiply them separate. So this guy, you just do negative 2 times 5, so I'd have a negative 10 out in front. And then the radicals are just like the last question. We're just going to squish them together. So I'm going to do 8 times 10, which would be 80. Okay. Now, does anybody know biggest perfect square that'll go into 80? 40 is not a perfect square, but 16 is. 40 does divide into 80, though, for sure. Should be 16. If you guys want to use a factor tree, you can do that too. But 80 is 16 times 5. That is the biggest perfect square. Okay, now, here's another question. We'll hopefully review from Algebra 1. So I'm going to take the square root of 16 so I can remove that, right? That's a perfect square. That would allow me to take a 4 out in front. If I already have something in front, what do I do with those two numbers? Multiply. Okay, so negative 10 times 4, negative 40. And then the 5 was left under the square root. All right, now the last one is a cube root, and I'm probably going to grab my calculator because those numbers are big and I'm lazy. So I'm going to do negative 16 times 32. Those are both under a cube root. So keep in mind this is a cube root, not a square root like the other two questions we just looked at. And it is totally fine to take the cube root of a negative number. And so I'm going to get here, when I squish these together, the cube root of negative 512. That is actually a perfect cube. Does anybody know what the cube root of that is? 8, and then just because it's negative, you just put a negative with it, and that's it. So negative 8, and then done. Is anybody having a question? Okay. I'm going to scooch this up. I'm going to skip, when we do this example here, I'm going to skip letter D in the middle. So we'll just practice a couple of these. So this is going to add variables into the mix. But it's similar to what we just did. The one thing to remember, when you multiply expressions together, they're both under a radical with the exponent properties we were talking about earlier. You just add the exponents on the variables that are the same. So I did this problem kind of almost to the end before I started, when I printed this. So if I do 54 times 5, that's where I got 270. M squared times m to the third would turn into m to the fifth. So just be mindful of that, because sometimes multiplication people will just accidentally multiply the exponents. You want to add the exponents on the variables that are the same. So that would be m to the fifth. Now, this is where I'm probably maybe grabbing my little yellow paper if I'm not super familiar with perfect cubes, and I'm looking at 270. If you look on this third column for your perfect cubes, 27 will go into 270. So I just rewrote that real quick as 27 times 10. And then I actually broke the variable back apart. This is what we were doing in our last lesson. We just take, and we want our exponent to be divisible by 3, since we're working with the cube root. Out of 5, the biggest thing 3 would go into would be 3. So I rewrote it as m to the third times m squared. Okay, so if I look back in here, the 10 is not a perfect cube, and the m squared is not a perfect cube, but everything else is. So what we can remove, cube root of 27 would come out as 3. M to the third, exponent divided by the index of the root, 3 divided by 3 would be 1, so cube root and third power cancel each other out, but we would still have an m. And then left underneath, I'm going to have the 10 and the m squared, so it'd be 3m, and then the cube root, 10m squared. And just don't, I know some of these problems look really complicated and they have radicals in them and stuff when you're done, but that's as simplified as that can get under a cube root, so that's just going to be my answer. Okay. Now, the one next to it, again, it's very similar to the one we did at the top. That was the square root with the -2, 8, and the 5 roots of 10. Numbers out in front, you just multiply them together and leave that out in front. So 3 times 2 is 6. And then I'm going to grab my calculator real quick here. I'm going to do 7 times 21, multiply the numbers. This is 147. And then just add the exponents on the variables that are the same when we're multiplying them together. So x to the third here, x to the third here, so it'd be x to the 6th. There's no y in that first term, so I'm just going to keep that exponent exactly the same. Anybody know biggest perfect square that will divide into 147? 49, yeah. All right, so I'm going to rewrite this real quick. 147 is 49 times 3. And I'm working with the square root, so I'm looking for an exponent divisible by 2. So I wouldn't break apart the x to the 6, because 6 is already divisible by 2. I'm just going to leave that alone. Y to the 9th, 9 is not divisible by 2. So out of 9, the biggest number 2 would go into would be 8. So I would rewrite this real quick as y to the 8th times y to the 1st, or just y. I'm just writing that exponent so you can see if I put that back together, I'd get y to the 9th. Okay, not perfect squares here. The 3 is going to stay, and the y is going to stay. Everything else we can take the square root of. So 49, square root there's 7, x to the 6th, exponent divided by the index of the root, 6 divided by 2 is going to come out as x to the 3rd. Y to the 8th, exponent 8 divided by the index of the root, which is 2, so this will be y to the 4th. And since there's already a 6 out in front, we're just going to multiply that with the 7. So 6 times 7 is going to give you 42. X to the 3rd, y to the 4th, and then still stuck underneath, I have a 3 and a y. Is anybody having a question so far? Okay. Let's try, I got a cube root here. So I have, make sure we're looking at cube roots here, perfect cubes. So I'm just going to do 50 times 5, which is 250. Now I have an x here, so don't forget that's like an x to the 1st. So there's 1 here, 6 more here, so it'd be x to the 7th if I multiply those together. And then this one, y to the 9th, y to the 3rd, 9 here, 3 here, so I have 12 total. This is all under a cube root. Anybody know the biggest perfect cube that would go into 250? 125 for sure. Okay, so I'm just going to rewrite that real quick. So it's a product of perfect cube, which would be the 125. And then that's just times 2. Now, x to the 7th, not divisible by 3 when we're under a cube root. So I'm going to break that apart. Out of 7, the biggest thing 3 would go into would be 6. So I would rewrite that as x to the 6 times x. And then y to the 12th, I'm going to leave that alone because 12 is divisible by 3, so that is a perfect cube. Now, what we don't have for perfect cubes here, the 2 should still be underneath, and the x should still be underneath because we don't have a perfect cube root here, but everything else we can take out. All right, so for the 125, I'm going to pull out under a cube root that is a 5. And x to the 6th, 6 divided by 3, this would come out as x squared. Y to the 12th, 12 divided by 3 would be 4, so y to the 4th. Everything I pull out in front, I'm just going to write it in front of the radical with multiplication. 5x squared y to the 4th, and then cube root left underneath a 2 and an x. I'm going to skip that one in the middle. Now you guys try this last one. See if you can put just this last one on the page. I'm just gonna skip letter D, but try letter E real quick. So scoosh that together. This one's a 4. So when you put it together and you're trying to break it apart, look at your 4 perfect 4s. And if we're doing the variables, we want the exponent to be divisible by 4. Can anybody tell me what, like, if you put it together with the multiplication, can anybody tell me what you got under the 4th root when you first started it? What'd you get? 16. Perfect. Okay. How did you break it apart at all? Oh. No, like, what did you do as your next step? Sorry, I said that wrong. Perfect. Good deal. Okay, p to the 3rd, the index is smaller than the root, so I can't even take anything out there, so just leave that alone. And then 2q to the 6 out in front, and then left under your 4th root, p to the 3rd. Does anybody have any questions? Because I'm trying to divide by 4. So it's only 3, so it's not, it would be like 3/4. You know what I mean? So I can't take anything out. If that was a square root, that's what I would do for sure. Good question. Does anybody else have any question? Okay, now the next side you're going to want your calculator for, because it's going to make some of these problems a lot easier. And I'm going to skip a couple problems here on the back. Okay. Now, on this example, and really this whole page could really go together, but we have done some division questions. So if you have any kind of a fraction with a radical, square root, cube root, whatever, the first thing I would tell you to do before you take a square root, cube root, 4th root, whatever you got in the problem, see if you can simplify the fraction first. Okay, so the very first problem I have back here just says 98 over 32, right, under a square root. I'm just going to grab my calculator, and if I haven't already told you this, I'm going to show you how to do it real quick. If you have a scientific calculator, those also do this, and I will be happy to show you how to do it on there as well. But for the graphing calculator, 83 or 84, it doesn't matter. Just do 98 divided by 32. I'm just going to hit enter, because I got to get a decimal on the screen before I do this. And then if you come here on the screen, it's the 4th button down on the left. It says math. I use this literally on a daily basis, maybe not in the summer, but anyway. So just hit math, and it's this big gross menu, but you just need the very first thing what says FRAC, that stands for fraction. So hit math, and then you hit enter twice, and it will convert whatever you just did, if it can, into a fraction in lowest terms. So it's just going to reduce it for you. You can do it by hand if you want to as well, but this might make you get the problem done a little bit faster, save you a little bit of time. Now, I have not taken a square root at all. This reduces to 49 over 16. All right, now, what I would do there, if you have all under the radical, you can do that together, or if you want to break it apart, you can take the square root of the top and bottom separately, which is what I would do for that question. What's the square root of 49? What's the square root of 16? There's your answer. That's it. And it was, if I tried to like break, divide 98, find the biggest perfect square and all, you could do that, but if you reduce it first, a lot of the times it makes the problem way easier to do. Okay, now the question right next to this, again, I would just check real quick. 11 does not go into 144, but if I was checking, if I did 11 divided by 144, hit my math, enter. If it gives you back the exact same fraction, which it does there if you test this one, that means it can't be reduced. So if that's the case, what I would do, just what I did on the last question, we take the square root of the bottom and the top separately. Now, 11, not a perfect square. Also, 11, not divisible by any perfect squares. There's no factor tree you're going to create that's going to bring anything out. So the top of that fraction would actually just be the square root of 11. That can't be simplified any further. What would the bottom of the fraction be, though? 12. Thank you. And that's it. So I'll do it separately. I'm going to skip letter C there. Okay, we're going to do a similar problem underneath here. But let me add some variables into the mix with D and E here. Okay, now 81, that's the only number in that fraction, so there's nothing for me to reduce or divide or anything like that. So I'm going to keep the 81. What I would tell you, though, with the variables, if you can use your exponent properties to simplify something, I would do that first before you take the square root. Okay, so I've got x to the 15th on the top and x to the 21st on the bottom. Where do I have more x's, the top or the bottom? How many more? 6. Okay, so I did not take a square root at all. I just simplified the fraction that was underneath, or I just simplified the fraction that was underneath the radical. Now, what I would tell you from there, this is super nice for us. I'm just going to take square root of the top and the bottom separately. Both of these end up being perfect squares in this question. Square root of 89 or 81 is 9, and x to the 6, exponent, index of the root, even though it's not written there, is a 2. So just take 6 divided by 2, be x to the 3rd, and that's your answer. And it's way faster than trying to break radicals and break variables apart and stuff like that if you simplify first. Okay, now one more real quick, and I just want to show you this because this has a fraction again. All right, so I got two numbers. I got a 2 on the top, and I got a 128 on the bottom. So you could probably reduce that by hand, but I'm just going to do my math under enter real quick to check. But 2 over 128 should reduce to 1 over 64. Okay, not take it. This is a cube root, and I have not taken a cube root. I'm just reducing. All right, so what I would do here, you can put the 1 on the top, but you don't have to. I'm just going to put a 64 on the bottom for the moment because I've got some variables involved here. And I got x's on the top and the bottom. So x's, do we have more on the top of the fraction or the bottom? Okay, the bottom, right? How many more? 12. Okay, so x to the 12th on the bottom. Those 17 on the top are going to cancel 17 on the bottom, but we would still have 12 left over. Okay, where do we have more y's, the top or the bottom? How many more? 15. So those 15 on the bottom would cancel 15 on the top, but we'd still have 15 left over. Okay, now, I did not take a cube root here. I did not do that yet. I just simplified that fraction. And then remember, you're working with a cube root for this question, not a square root. So once I simplified that fraction, I would just go ahead and take the cube root of the top and the bottom separately. Can anybody just raise your hand and tell me, what would the top of the fraction simplify to be? Y to the 5th. Good. All right. What about the bottom? Yeah, 4x to the 4th. Perfect. And there's no radical left, and we're good. Is anybody having a question? Okay, I'm basically going to do some more of the same problems, but just kind of down here. It was kind of telling you you can interchange between, if you want to take the square root, cube root, whatever you're working with, of the top and bottom separately, or if you want to put them together. So all the questions in this example, which we're going to skip a couple of these down here, these are written with the top and bottom separately. Okay, here's what I would tell you to do. Again, even though they're written separately, before I do the problem, I would think about this for this first one. I have cube root of negative 375, cube root of 3. Think about this as one fraction all under a cube root, just real quick before you do the problem, and see if it can be simplified. So if I'm just going to grab my calculator here real quick. If I do negative 375 divided by 3, which I'm not on the screen, so let me pull that down. That actually reduces to negative 125. So it was written separately, but you can also interchangeably think of those as being together. I would put them together and simplify first. You don't have to write out that work, but just think about that. This is really then the cube root of negative 125, and that's actually a perfect cube. So this is just negative 5. So if they're written separately, you can put them back together as just one fraction under the cube root. or you can work at whatever is easier for you, but I would definitely simplify first. So like on this one, first thing I would do, these are both under a square root. So I would think of this whole thing as 27 over 243 under just one square root. So if I'm going to do my math, enter here. So 27, fail, I'm not on screen, 243, math, enter. This is really 1/9. All right, so I didn't take a square root, I just reduced it. You always want to reduce first, so this is 1/9. Then, perfect square, right? Because square root of 1 is 1, square root of 9 is 3, and that's my answer. And that's all you have to do. All right, I'm going to skip C and D because I want to give you guys some time to work on your homework today. But let's do E and F here. All right, so each one of these is just a little bit different. Now, I will tell you, E is a little bit more complicated than some of the other problems we've been working on because you're not going to have perfect cube in this situation. So first thing I would do, and you absolutely do not have to rewrite this, but I'm just going to rewrite it real quick on my paper. I would think of this as all 3m to the 8th over 192 mn to the 3rd. Now, if you do have, like I just have an m in the bottom of that fraction, do remember they don't typically write it in the notation, but that does have a first power. So when I simplify that, I want to think about that. What I would do first there, take 3 over 192 and see if you can reduce it. So I'm going to do that, math, enter, 1 over 64. Okay, so I have not taken a cube root at all, but I'd have a 64 on the bottom of that. Now, where do we have more m's, the top or the bottom? How many more? 7. Okay, so I didn't take a cube root, but the top of this would simplify to be m to the 7th. Now, I only have n's in the bottom of this fraction, so n to the 3rd in the bottom. There's nothing in the top that would cancel anything there. Did not take a cube root yet. Okay, now, this is different than some of the other problems because it's not a perfect cube all the way around to do this problem. This is where I would definitely take the cube root of the top and the bottom separately. The top of that, I'm going to save for just 1 second. The bottom is a perfect cube. 64, cube root of 64 is 4. N to the 3rd, that exponent is divisible by 3. 3 divided by 3 would just be 1. So the bottom of that would just be 4n. Okay, now the top, I would break apart like we were doing in our last lesson, right? So cube root, 7 is not divisible by 3, so I would break that apart. Biggest number out of 7 that 3 would go into would just be 6. So I would do m to the 6th times m. The perfect cube there would be to take 6 divided by 3 to get m squared pulled out in front, but I'm not totally a perfect cube, so I should still have a radical in the answer. So the top of the fraction would be m squared times the cube root of m. A little more complicated there. All right, does anybody have a question? Okay. Very last one is actually a 4th root, so we want to make sure we're thinking about looking on that list of perfect fourths. So I'm going to think about, and again, you do not have to rewrite this, I'm just going to rewrite it real quick. I'm going to think about this as that 1024x to the 15th all over 4x, just the whole thing under a 4th root. And I want to reduce that first. So if I take 1024 and I divide that by 4, it's not a fraction, right? Because the bigger number is on the top. That actually just reduces to be 256. And then with the x's, kind of the same thing. This 1x on the bottom is going to cancel 1 on the top. You're not going to have a fraction here if you simplify this first. This should be 256, and then it would be x to the 14th. Now, if you're looking at your lovely little list of perfect fourths, you'll see 256, that 4th column, 256 is the 4th number down. So that's good for us because that's a perfect fourth. So I'm just going to leave that alone for 1 second. And x to the 14th is not a perfect fourth because 14 is not divisible by 4. So biggest number out of 14 that would go, what 4 would go into would be 12. So I would do x to the 12th times x squared there. And then I'm going to remove any perfect fourths. So 256 is going to come out as 4. x to the 12th exponent divided by the index of that root would become x to the 3rd. And then still left under my 4th root is going to be the x squared. Okay. Is anybody having a question?